This video is from chapter 3. It's the first part of 3.1. It's on functions. We're going to define the functions and look at the notation that we use. We should have covered all of this before, but I just want to be precise about what a function is. So, a relation between two things is just some relating of them together, right? So you and your class are paired up, right? So that's a relation. Numbers can be paired up. Your age and your height can have a relationship. Anything that is related can be talked about as a relation. Now, a function is a specific kind of relation. So if you're taking things from one set and matching them up with things from another set, like students and classes, right? Then a function would be, if everything in the first set, that's called the domain. So you take every item in the domain is assigned exactly one item in the range. Okay, so that exactly one, that is the important thing here. One element in the range. All right, so let's look at an example. If we take a person and match it up with a birthday, okay, each person has only one birthday, right? That would be a function. If we take it the other way around and we take the day of the year and we match it up with person born that day, for each day of the year there are many people born that day, okay? So this is a function, this is not. So here's another way of looking at this. So here we have the set, that's the domain. This is the set that we start with, right? Each of these items in the domain, which is A, B, C, and D, is matched up with one item in the range. Now, if you notice here, A is matched up to F of A. That's just the notation that we use. So it means that this is whatever you get when you plug in A. Okay? This would be a function. Now, suppose this was also connected here, so that B went to both F of A and F of B. Then it's not a function. Okay? We can't have one item in the domain going to more than one item in the range. Yet, some people like to think of it as like a function box, right? And we sometimes write our functions as an equation, right? So in this case, the function is to cube, right? We're going to take each number that we input and we cube it. So that means when I put in 0, I get 0 out, right? And lots of times we write our function information as an ordered pair, right? This is my x, or the domain. This is the y, or the range. So I put in 0, I get out 0. If I put in 1, I get out a 1. If I put in 2, I get out an 8. Right? If I put in 3, I get out a 27. So in that case, this equation right here is our rule for the function. A graph is another way that we sometimes describe a function, because it's showing that relationship between x and y. So we have our, if we look at this one right here, we have our x. This tells us our x. This tells us our y, and this tells us the relationship. So when x is 2 and y is 1, that's one of our relationships. Okay, you can tell that it's a function if for any x there's not 2 places that it hits the y. So say like this one, if we look at this one, let me get rid of these now. If I draw a vertical line through here, I see that it's supposed to be vertical. When x is 4, it actually hits in 2 places, right? So that means for x being 4, there are 2 y values. So this one is not a function. Okay, so the second one here, you see that if I drew a vertical line anywhere on here, if I would actually draw the whole vertical line, you see though, it doesn't hit. It doesn't hit twice. So this is a function. Okay. Let me try drawing it with different color here. So if I look at the vertical lines on this one, you see it doesn't hit twice. But this one, it does. So we call this the vertical line test. When we're looking at a graph, we can tell whether it's a function by this vertical line test. So another way that we represent functions is by their equations. We already mentioned that. This is the most common way because we can do things algebraically with it, right? So you notice that the f of x, so this is not f times x. F is a variable, but it represents a function, so it doesn't represent a number. It's not multiplied. It's kind of like f is the function and x is the thing that we put into the function. Okay, so this is a function of x is how we say it. And this one is g. So this function is g, this function is f. We can name them whatever we want. Most commonly, it's going to be f. Or letters from the middle of the alphabet there. But we could name, sometimes we call, like, we might say C of x when we're talking about the cost in business. Or other things, so that the name of it, somehow relates to what we're calling it. And that's fine. We can call it whatever we want, but most commonly you're going to see it as f. What this notation means is that if I write a number in there, say like 2, that means that everywhere there's an x in the function, I'm going to put a 2 instead. So it will be 3 times 2 minus 2, or 6 minus 2, or 4. Alright, so we have f of 2 equals 4. That means that the ordered pair 2, 4 is part of that function. Now, we look at g, and I could put 2 into g as well, and it will be totally different. right? So g of 2 would be 1 minus 2 squared. So do the squared first. That'd be 4. 1 minus 4 is negative 3. So when I put in 2, I get out negative 3. So it doesn't have to be x. So here's a function h of t equals 5t squared plus 3t minus 6. So all this means is that this is a function of t instead of a function of x. T is the domain. H of t is the range, right? So look what happens if I put a negative in. So you may have noticed that I always put parentheses around the thing I'm plugging in. If you do that, you won't lose track of these negatives particularly, and then you follow the order of operations after that, right? So we're going to do the square first. That negative 1 squared is positive 1. So I have 5 times positive 1, so that would just be 5. And then I have 3 times negative 1, so that would be negative 3. And then our negative 6. So 5 minus 3 is 2, and 2 minus 6 is negative 4. So the thing to watch out here is to be careful about plugging in the negatives particularly. Now, I can plug anything in here. I can even plug another equation in here. So instead of t, let's suppose I want x plus 1. That means everywhere there's a t, I'm going to put x plus 1. Okay, yeah, I'm going to do this x plus 1 squared. I have to multiply it all out, distribute it, right? Or maybe you want to call it FOIL. Some people like to call it that. So, so it's going to equal 5 times, now I'm going to square this all out. It turns out to be x squared. Then, you know, here's what I'm doing is, I got x squared, and I got an x and another x, so that would be my 2x. And then I have the 1. Still all multiplied by 5. Now I'll just go ahead and distribute this. And now I can distribute this. And then add all the like terms. So I have 5x squared. I have 10x and 3x, so it would be 13x. And I have 5 plus 3 is 8, minus 6 is 2. So h of x plus 1 is equal to this. In this case, I changed it to a function of x, right? So that's what I got when I plugged in that thing there. Okay, here's your quiz question for 3.1a. You're going to find f of negative 2. And here's your f. F of x is 5 minus 3x squared. Go ahead and write that down and then figure it out. Put it into the quiz on Canvas.